Okay, in this little video, this will be my fifth in a series of 5, and so these are all videos on functions. Hopefully the playlist exists to where you can find it easily. For this one, we're just going to take a look at a few functions and try to find its domain and range. So we're also going to go through function notation to describe what the way that we're writing our rules. So before, I told you you could think of a function as kind of a set of directions how to go from one place to another. And again, you can't be in more than one place at once, so you can't actually travel to 2 places. That's not allowed. That's bad. Now, because of that, we also have to develop this rule. And back in the 1700s, Euler decided, all right, you know what? We all need to talk the same language. So I'm going to go ahead and I'm going to create a notation for functions. And thus, f of x was born. This is read f of x. It is not multiply. It is of. This is a little bit different. So if, for instance, I were to say, f of x is equal to 3x minus 5. I'm telling you that 3x minus 5 is a function, and the domain of it is x, whatever the x values are. We can take a look at this and look at the graph and determine, is it a function or not? And for our purposes, if you just graph it on a calculator, yeah, sure, you can determine that. It may change later on depending on the complexity of the problem. So here we go. If I press the y equals button, and this is true for the 83 and the 84 all together, the colors will look a little differently, but they operate in the same fashion. I'm sorry, I do not have the Inspires. I'm not cool enough to have enough money to buy one, and my college doesn't think that we should have them quite yet. I'm sure we will get into them. So they may have some functionalities that these calculators don't currently have. Anyway, so if I push y equals x, or I'm sorry, the y equals button, I can just put in 3, and then the x key is kitty corner to the second button. So pressing that, and then I'm minus 5. The minus key and the function and the operator keys are over here in gray on the 84. I believe they are in blue on the 83. The little negative sign down here literally is a negative, and the calculator knows the difference between negative and minus. They are not interchangeable on the calculator. Once I have that, for the sake of our purposes, I always recommend students go to zoom and then option number 5 for zoom square. What it's going to do is it's going to the screen on the calculator is ever so slightly wider than it is tall, so it creates an artificial stretch in the x direction. So in the width, it kind of stretches out the graph. This square thing changes how the window is set up so that it brings it back in so that it looks like it's the same measurement all the way around. So this is what this graph will actually look like if you were to graph it on paper, on graph paper anyway. So we look through it and we see, okay, well, if I draw a vertical line all through here, it doesn't look like it's going to hit more than once. It's a function. Perfect. All right, well, now let's find its domain and range. So I have a domain question. The domain, remember that the domain is the set of all possible x values. Not the ones you see, but all possible x values. There are certainly a couple of different ways that you can write this. I tend to teach my students some very basic notation for mathematics, such as if I wanted to say x is a real number, then I teach them that x is an element of the set of real numbers. I give them at least that much. So we can express the domain as the set of all real numbers. That's perfectly fine. If you're more into interval notation, x, it looks like I can throw anything in there. And to confirm this, just pick a few weird values of x. Like 0 is always a weird value of x for some reason. If you plug in a number, do you get a number out? That's the true test to it. So we have 3. We get, if I make x 2, then I get 6 minus 5 is 1. Yeah, I get a number out. If I put in 0, then that whole thing goes away and I get negative 5. I get a number out. If I put in 1,000,000, then I just multiply it by 3 and subtract 5. I get a number. So it seems like all of the real numbers will work. which means the interval that the domain will take up is negative infinity to positive infinity. All real numbers. This is another way to write it. The range, this is where a lot of the times it changes. But the range is, again, the set of all y. So now the question is, if we look at the graph, it's usually much easier to look at the graph. As you advance, there are other techniques to measure this. But anyway, as you look at the graph, does it seem like it's going to stop going up or down at any moment? And it seems like it's just going to continue in both directions. So in this case, the y is also a real number. Remember, they don't have to match when you list them in set notation. It also goes from negative infinity to infinity, including any real number in between. So again, infinity and negative infinity are not numbers. You cannot reach them. That's why the parentheses. It just means that you can't touch them. So this is a way that you can find domain and range. If we take a slightly more complicated one, let's take, let me come up with another one here. Let's say that we have a function. I'm going to just tell you straight out that this is a function. We're going to have the function x squared. So what we can do is we can go over here to our calculator, press the y equals, pressing clear, or you can disable it, either way. And then we're just going to push this x button, kitty corner of the second key. And then we're going to press the little square button, that's kitty corner of the 7. That should put up a little square here. Okay, so now we can go ahead and graph that. I'm going to zoom in 5 again. If you haven't changed your settings before this, then your same settings will be applied. So you could just press graph if you wanted to. So now we see this, we have this weird curvy looking thing. This is called a parabola, and all of the x squared family looks like it. It just opens, closes, it points down, opens, closes, or it shifts left or right, up or down. That's it. That's what the way the family works. So now the question is, what is the domain? Well, there's actually a fun thing. See, the domain of all polynomials is all real numbers. Every polynomial has all real numbers as its domain. So this is going to be all real numbers. I'm just going to stick with interval notation. It seems to be the most common. And then the range now, this is a little bit weird. See, it comes down, it stops, and it goes right back up. So there's some stopping point there, and we want to go find it. If I press the second key and I press table, then I can look at the values of y, and I notice, oh, look at that, it's coming down, down, down. Oh, it stops. Oh, now it's going back up, up, up. So it looks like somewhere around 0 it bottoms out. If I take a look at the graph again, it looks like it does in fact bottom out at 0. Remember that y equals 0 is the x-axis. It doesn't seem like it goes below it. You could check that, I suppose, but you'll find out that it does not, in fact, go below the x-axis. This is the vertex 0, 0, and that is the low point. And so, taking a look at that, our range then, it can go as low as 0 or as high as infinity. It looks like it just continues up in that same direction. Now, you can't ever be infinity, so it gets a parenthesis. However, it can touch 0 in this case. So it gets a bracket. So this is the range in interval notation. It goes from 0, inclusive, meaning you can count 0 right along in the solution set, all the way up to positive infinity. There are some restrictions like this. All of the even polynomials look like this in some fashion. They might do some squiggly stuff in between, but eventually they either come down and go back up, or they come up and go back down. The odd ones, the ones that are like x, x cubed, x to the 5th, that sort of thing, they're going to start below, come up, do some weirdly funky stuff, and then shoot back out the top, or they're going to come out of the top, do some funky stuff, and then shoot down out of the bottom. They're going to split. So all of the evens have a restriction on their range. All of the odds have all real numbers as their range. These are not the only types of functions you can see. So now let's take a look at an example, for instance, where we have an issue with the domain, and then we'll see how to deal with that. Let's take the function 1 over x. This is the simplest of them all. I'm going to get rid of this here. I'll bring it up and show you what the graph looks like. But we can take a look at this and actually figure something about the domain. The domain of this. Well, if we put a negative in here, we get 1 over a negative, which is just negative. Okay, so that's a good number. If we put a positive in for x, we get a 1 over a positive number, which is just going to be whatever that is, but it's going to be positive. So we get a value. The problem comes in when we start looking at 0. Is it possible for the denominator to ever be 0? Because if it is, we can't allow it to be. 1 over 0, we don't know what that is. It's undefined. We can't do it. There's no division by 0 allowed. So we have a distinct issue. X cannot be 0. So what we do is we kind of do a little hop. So what we're going to do is we're going to count all of the stuff up to this point, and then we're going to hop over 0 and continue on. Here we go. We're going to start at negative infinity. We're going to go up to 0, but we can't touch it. Then we're going to hop. Then we're going to start up on the other side of 0 and continue on to positive infinity. And for my class, I have this stupid saying where, you know what, if your domain ends up hopping, it's 1, 2, slap a U. That means the union of these two. You say this or this. So you can count both kind of as the same amount. Now what this does say, however, it also excludes 0 because you can never actually equal 0. You can begin just on one side of it or just on the other side of it, but eventually you have to hop over it. The range, however, will have an issue as well. See, the range goes from negative infinity to 0 as well. This can never be 0. There's no number x that you can put into this and make 0. You can make every other number as far as that goes, though, using real numbers. So again, we have this 1, 2, slap a U, and 0 on either side. So now the question is, okay, well, what does this look like, and why is it so jacked up? So let's see. We're going to attempt to divide by 0 here. We'll put in, I'm going to clear this and put in 1 divided by x and hit graph. Remember, we're still in a square thing. Ooh, oh, that's nasty. I'm going to zoom in to see what's going on. I'm zooming in centered at 0, 0, and it's going to go in by a factor of 4. Well, that's weird. That's really strange. So we have some behaviors here happening where it looks like x is getting rather large, and that causes 1 over x to get really close to 0. Strangely in both directions, which is kind of true. You put a big number in for x, 1 over a big number is a really tiny number. Likewise, as you approach 0, so x is getting incredibly small, smaller than 1. If you divide by a number smaller than 1, the value goes up from the number that was the dividend. So 1 divided by 0.5, for example, is 2. It's increasing, so it's bigger than 1. And then if I were to put 0.0001 in here, then you would get 10,000. So that's going to really shoot up. Again, you're never actually reaching 0 because if x was 0, this would blow up to infinity. And that's really bad. Likewise, on the zeros this way, you can't ever get down to 0. So you can put a number as big as you want into x, and you never actually get 0. For those of you in calculus about to argue with me with the whole limit thing, I get it. But the limit still is something that we're not talking about. We don't understand this concept. And remember, the limit is not you go to that number. The limit is as it tends that way, what does it look like it's continuing to do? So, yeah. Anyway, this is the rough introduction to how to find domain and range on a function that you can see. If you can't see it, sometimes you can make some guesses about it, and then later, if you continue on in mathematics, we'll give you some techniques that you can use to absolutely find it. All right, I hope that all of these videos helped you better understand functions and how they work and how to express them and how to find their domain and range. That's primarily it. After that, it's just smooth sailing from here on out. Talk to you later.